Topic is function oriented software design. సో దీనిలో ఓవర్ రివ్యూ ఆఫ్ ఎస్డి మెథడాలజీ ఉంటుంది. ఫస్ట్ ఎస్ఏఎస్డి మెథడాలజీలో స్ట్రక్చర్ అనాలిసిస్ అండ్ స్ట్రక్చర్ డిజైన్ మెథడాలజీ ఉంటుంది. సో షోన్ ద ఫిగర్ ఇన్ structure analysis SRS document is transformed into data flow diagram. Here see the picture. First make the SRS document. SRS document is transformed into DFD model based on the structure analysis, and then DFD model is transformed into structure chart based on the structure design. Here first point is during the structure analysis the SRS document is transformed into data flow diagram model, and then during the structure design so the DFD model is transformed into structure chart. Here shown in the figure, structure analysis activity transform the SRS document into a graphic model called the DFD model. During structure analysis, functional decomposition of system is achieved. So each function that the system needs to perform is analyzed and hierarchical decomposed into more detailed functions. On the other hand, during structure design, all functions identified during structure analysis are mapped to module structure. This module structure is also called the high-level design or the software architecture for the given problem. This is represented using the high-level design is a stage normally followed by a detailed design stage. During the detailed design stage, the algorithms and the data structures for the individual modules are designed. The detailed design can directly be implemented as working system using a conventional programming language. So it is important to understand that the purpose of structure analysis to capture the detailed structure of the system as perceived by the user, whereas the purpose of structure design is to define the structure of the solution that is suitable for implementation in some programming language. The result of structure analysis can therefore be easily understood by the user. In fact, the different functions and data in structure analysis are named using the user's terminology. The user can therefore even review the result of the structure analysis to ensure that it captures all these requirements. So, we have already mentioned during the structure analysis the major processing tasks. Tasks means high-level functions of the system are analyzed, and the data flow among these processing tasks are represented graphically. The structure analysis technique is based on the following underlying principles. Then one is the top-down decomposition approach, and another one is the application of divide and conquer principle. Through this, each high-level function is independently decomposed into detailed functions. So graphical representation of the analysis results using the data flow diagrams. Actually ఇక్కడ డేటా స్ట్రక్చర్డ్ అనాలిసిస్ అంటే మనకి ఫస్ట్ పాయింట్ వచ్చేసి హై లెవెల్ ఫంక్షన్స్ ఉంటాయి. హై లెవెల్ ఫంక్షన్స్ అన్నీ కూడా డీటెయిల్ లెవెల్ ఫంక్షన్ని ట్రాన్స్ఫార్మ్ చేస్తాయి. అంటే ఇక్కడ టాప్ నుంచి డౌన్కి డికాంపోజిషన్ అప్రోచ్ ఉంటుంది. అలాగే అప్లికేషన్ అనేది డివైడ్ అండ్ కాన్క్యూర్ ప్రిన్సిపల్ని ఫాలో అవుతుంది. సో ఈచ్ హై లెవెల్ ఫంక్షన్ ఈజ్ ఇండిపెండెంట్లీ decomposed into detailed functions antam. So the high level functions are transformed into detailed functions. So and another one is the graphical representation of the analysis results using data flow diagrams. Here the DFD representation of a problem. DFD representation of a problem as well as see shortly is very easy to construct through extremely simple. It is very powerful tool. Tackle the complexity of industry స్టాండర్డ్ ప్రాబ్లమ్స్. ఇక్కడ డిఎఫ్డి రిప్రజెంటేషన్ అనేది ప్రాబ్లం. సో ఇది షార్ట్గా ఉంటుంది, వెరీ ఈజీగా కన్స్ట్రక్షన్ చేయొచ్చు, ఇట్ ఈజ్ వెరీ పవర్ఫుల్ టూల్ అని కూడా చెప్పొచ్చు. సో కాంప్లెక్సిటీ ఆఫ్ ఇండస్ట్రీ స్టాండర్డ్ ప్రాబ్లమ్స్ అని కూడా చెప్పొచ్చు. ప్లీజ్ నోట్ దట్ ద డిఎఫ్డి మోడల్ ఓన్లీ రిప్రజెంట్స్ ద డేటా ఫ్లో యాక్సెప్ట్స్ and does not show the sequence of execution of the different functions and the conditions based on which function may or may not be executed. So completely ignores aspects such as control the specific algorithms. So next one, DFT, data flow diagrams, also known as the bubble charts. ఈ డేటా ఫ్లో డయాగ్రామ్స్ అనేవి మనకి బబుల్ చార్ట్లో ఉంటాయి. ఇట్ ఈస్ ఎ సింపుల్ గ్రాఫికల్ ఫార్ములైజ్ that can be used to represent a system in terms of the input data to the system, whereas processing carried out on this data, the output data generated by the system. The main reason why the DFD technique is so popular is probably because of the fact that DFD very simple formalism. It is simple to understand and use. DFD model uses very limited number of primitive symbols. So here show the figure. Symbols used for designing DFD. It is a external entity. It is the process. So external entity is the input data. Data flow is the arrows. Process is also input data. So it is the output process. And data storage. Here storage location. Then go for another diagram. Here functional symbol. A function is represented using a circle. ఈ functional symbol అనేది represented using a circle. The symbol is called a process or a bubble. So bubbles are annotated with the names of the corresponding functions. And external entity symbol. External entities such as a librarian. A library number is represented by rectangle. So ఈ functional entity symbol అనేది rectangle symbol లో ఉంటుంది. The external entities are essentially those physical entities external to the software system which interact with the system by inputting data to the system by consuming the data produced by the system. In addition to the human users, external entity symbols can be used to represent external hardware or software, such as another application software that would interact with the software being modeled. So next data flow symbol, a directed arc, an arrow. So an arrow is used as a data flow symbol. A data flow symbol represents the data flow occurring between two processes or between an external entity and a process in the direction of the data flow arrow. Data flow symbols are usually annotated with the corresponding data names. Data item number flowing from the process, read number to valid number, data item following into read number, and valid number flowing out a valid number. So data store symbol. A data store is represented using two parallel lines. It represents a logical file. That is, a data store symbol can represent either a data structure or a physical file on disk. Each data store is connected to a process by means of data flow symbol. The direction of the data flow arrow shows whether data is being read from written into a data store. So output symbol. The output symbol is shown figure 6.2. The output symbol is used when a hard copy is produced. So the notations that we are following this text are closer to the addends notations than to the other notations. We may sometimes find notations in other books that are slightly different than those discussed here. So synchronous and asynchronous operations. Two bubbles are directly connected by a data flow, then they are synchronous. This means that they operate at the same speed. An example of such arrangement is shown in the figure. Here the validate number bubble can start processing only after the read number bubble has supplied data to it, and the read number bubble has to wait until the validate number and bubble has consumed its data. However, two bubbles are connected through a data store in figure 6.3. Then the speed of operation of the bubbles are independent. This statement can be explained using the following reasoning. The data produced by a producer bubble gets stored in the data store. It is therefore possible that the producer bubble stores several pieces of data items even before the consumer bubble consumes any of them. Here see the picture. Here this is the read number. So given the data flow arrow, it is a data item, and after read the number, it is a circle or bubble input process of the data. After bubble, so give the number is directly connect to another circle, validate number, and finally gives the output is a validate number. These two bubbles are directly connected with data flow arrow is called synchronous operation of two bubbles. Now another diagram. Here data item and read number and connect the number. So connect the number is also a data item and it is a validate number and output is valid number. So here two bubbles are direct connected, not directed connected with number. So it is a asynchronous operation of two bubbles. Next, data dictionary list all data items that appear in a DFD model. The data items listed include all data flows and the contents of all data store appearing in all the DFDs in a DFD model. Please remember that the DFD model of a system typically consists of several DFDs. Level 0 DFD level 1 DFD, level 2 DFDs. As shown in the figure discussed new subsections. However, single data dictionary should capture all the data appearing in a DFD construct in the DFD model of a system. Here data dictionary lists the purpose of all data items and the definition of all composite data items in the terms of their component data items. For example, data dictionary entry may represent that the data gross pay consists of the components regular pay and overpay. Here gross pay is the data dictionary and regular pay and overtime pay. Here both are combined in a gross pay. Gross pay, regular pay, gross pay is a integer number and regular pay plus overtime pay both are integer numbers. Here composite data items can be defined in terms of primitive data types using the following data definition operators. So place denotes decomposition of two data items. Example A plus B represents the data A and B. So in square brackets double colon represents selection. Any of the data items listed inside the square bracket can occur. For example, A comma B represent either A occurs B. So in brackets the contents inside the bracket represent optional data which may or may not appear. So A plus in brackets B represent either A or A plus B occurs. In flower brackets represent iterative data definition. Example, in flower brackets name 5 represents 5 named data. So represents data or more instance of named data.